Hello, everyone. Welcome to the August Recreational Astronomy Night Meeting, online version of the Toronto Centre RASC. My name is Paul Markov, and I'll be your virtual host for this evening. I hope you've been able to take advantage of the excellent observing weather we've had during the past several weeks. In fact, we have great skies once again here in Toronto tonight. Now, we have 3 speakers this evening as usual, and I expect we'll be done by about 9:30, so you can still get some observing done if you'd like. Before we get the meeting started, I'd like to thank in advance our technical team comprised of Andrew and Betty Reed, Blake Nancarrow, Ward Legros, and Ennio Cilucci. Thank you guys for making these online meetings possible. So the speakers for tonight are as follows. We have Blake Nancarrow with The Sky This Month, followed by Denis Zaytsev, and he'll talk about something called INDIHUB. It's the network of backyard telescopes and citizen science platform. And Jerry Vila will speak next on Nicolaus Copernicus and the start of the scientific revolution. And finally, our president, Ralph Chu, will close the meeting with the announcements as usual. If you have any questions for our speakers, you can enter them in the YouTube chat box, and Ennio will ask the speaker your questions at the end of the presentation. And also, if you're attending our meeting for the first time, whether you're a member or not, please let us know through the chat as well. So without anything further ado, let's begin the meeting with Blake Nancarrow and The Sky This Month.
Hi, thanks for having me. The Sky This Month presentation for this period, it doesn't fit perfectly within the month. You can see the dates on my initial slide here. We're going from today and we're going to the next Recreational Astronomy Night meeting, and that's in the middle of September. So I'm talking a little bit about what's going on in August and then a little bit at the beginning of September. As usual, I've made an article. It's on our website now. It's live. You can see the web address is noted on my slide there, and we're going to share that in the YouTube chat. If you look up that web article now, you'll find that there's a downloadable calendar, a PDF file. As usual, I've got various things noted on a day-by-day basis, and I use my little icons like an eyeball or binoculars to inform you as to the equipment that you might haul outside to do that observing. I've made observing lists for some of the popular software applications with planning capabilities, and I've got all the links that I'm talking about, plus a few others there. If you have a QR code reader on your phone, you could take an image of that or capture that QR code, and that'll take you directly to that web article. If you're typing in that web address, watch out that it's case sensitive. You need the uppercase letters for The Sky This Month. And as Paul mentioned, I remind you to type in any questions into the YouTube chat, and do that at any point. Don't leave your questions to the end. As soon as things pop into your head, type them in, and I'll try to answer those questions for you. So let's go. Here's the particulars about the sun right now. You can see that it rose today for the Toronto area or points nearby at around 6:30. It's setting in about 45 minutes from now, so 8:15. But of course, it doesn't get really dark until sometime later when the sun is well below the horizon. We refer to that as astronomical twilight. So that starts at 10 p.m. and it concludes at 4:40. That's today. So when you crunch those numbers, that's giving you about 6.5 hours of darkness. But by the end of that time period that I'm reporting on, you can see all these times have shifted a little bit. We're in the steep part of the hourglass. Note those hourglass shapes on the right. Those are from the Sky and Telescope website. The time that the sunrise is changing, the time that the sunset is changing is very rapid at this time of year. So by the end of this period, about 4 or 5 weeks from now, we're up to 8 hours of darkness. I suppose that people like their hot summer days at the cottage. This is maybe not good news, but I always like these longer nights. There's lots of stuff going on with the moon. There are all the phases that I've noted in that table on the left side. I got gypped, actually. It's not fair. The new moon happened yesterday, and the next new moon phase is on September 17th. So I don't get a new moon in my time period. Boo! But that means if you want to do deep sky object observing right now, you got to do it now over the next week or so, while the sky is quite dark, and then early September to the middle of September, that's your next dark sky period. I've also noted some particulars about when there's something interesting going on the moon, or it's near a planet or a deep sky object. That graphic, by the way, is from the European Space Agency, and I'd like you to look at it closely there. What's wrong with it? There's one thing that I think is technically wrong, and that's surprising because this came from a space agency. But there's another thing that I don't think is sort of appropriate or well done. So I have a couple of issues with that diagram. And I after a while, I thought, I'll make my own, but it was taking too long. So it's pretty good. One of the things that's going on with the moon next week is the appearance of the lunar X. This is quite a stark feature on the moon. Let's zoom in here. Tanya got a really nice photo of it near the center of the inset photo. At about a little bit down from center, you can see an X pattern. That's just due to the Claire Obscura effect, the lighting angle of the sunlight hitting the top edges of some craters. Head towards the Purback crater or one of those other craters. Now this effect starts at 6:10, so obviously the sky is still bright from my previous solar table. But the peak event, I predict that it will occur just after sunset, and it will carry on. The whole thing lasts for about 4 hours. So check that out. You do need a medium to a large telescope to see this feature because it's pretty small, or a long camera lens. Ideally tracking, you should be able to do that. Tanya shot that afocal just holding up her phone to a telescope, so that's cool. Here's another feature. I've looked at this a couple of times, but I've never had a really good look, and I forgot back in June when the phase was optimal for this. But on the 26th, you can see the railroad or the straight wall. Technically, this is a Rupus rectus feature where there's an elevation change in a crater or a maria, where it's a little bit like the Niagara Escarpment. You have a high elevation, there's a big drop. The elevation changes about 250 meters, 300 meters. So again, we'll zoom in here. The Lunar Reconnaissance Orbiter got a nice photo of that. So you can see this nearly perfectly straight black line in the middle of Mare Nubium. So that's just due to the wall, the lower level, not being in the sunlight. So that's a neat sort of feature to look for. So a couple of interesting things going on with the moon. Now, this is not optimal time or the main event for Mars yet. That's happening later this year in October, but Mars is getting closer to us, or rather we're getting closer to it. And there is a notable event that happens within this time period, that on September 9th, the fourth planet will appear to stop moving against the background stars. So it's moving in a normal motion from west to east for the next little while. And you can see I've put the little UR here, where the moon's pretty close to New Piscium right now, but then it will slow down, stop in reverse direction. That's retrograde motion, and that's just the effect of us being on the faster track, closer to the sun. And then it's October 13th. That's sort of the big date when we're at opposition. The point is that Mars is getting bigger, it's getting brighter, and features will become easier to see over the next little while, including the southern polar cap. So that's something to look for. There's a very nice photo by Elaine and Tony, and that was just a couple of days ago with a 150 millimeter instrument. So keep an eye on Mars. Look whenever you can. It's just going to get better and better over the next little while. And it's also interesting to note that there are 3 spacecraft on their way to the 4th planet right now, all due to arrive in February. Jupiter, even though it's past its opposition, I think we missed the oppositions of Jupiter and Saturn because of that crazy comet. 2020 F3 Neowise was distracting us, but Jupiter is still quite good right now, and it's still pretty big in the sky. And I started to look into it, and I was starting to put in my little calendar sort of when interesting events were happening. But I found in short order that there were so many things going on at Jupiter that I couldn't fit them. It would have overwhelmed my calendar. So I stopped. The bottom line is just about any evening that you look at Jupiter over the next 4 weeks, you're going to see something interesting. And that includes the Great Red Spot going through the middle of the planet. Imagine a line going straight down through the middle of the planet from the North to South Pole. That's the meridian. So we have GRS crossings when it crosses the meridian. We have the moons going in front of the planet. This photo by Claudio does not show any moons in front of it. You can see that 2 of them are off to the side. One's out of frame, and I believe one's behind at this time. But you can also, if you look closely at that photo, you can see there's a little inky black dot there, and that's a shadow caused by that nearby moon. So shadow transits are happening. There's a lot of those occurring. We also get occultations where a moon simply goes behind Jupiter, and Jupiter just blocks it from our view. And we can also get eclipses, if you can sort of figure out the math of this in your head. The sun's at a different angle from the Earth, so there's a large shadow or shadow cone behind Jupiter, and when a moon goes into that, it will suddenly disappear. Or it may emerge from the eclipse, and the moon will pop. It'll suddenly appear. And I'm not talking about behind the planet. It's just out in space, and it will go into the shadow or come out of the shadow. And it's pretty neat when you see those. A little heads up, if you use Stellarium, the free software for the PC, the Mac, or the Linux platform, Chris Vaughn and I were corroborating our notes, and we found that the positioning of the Great Red Spot is not correct. If we put in the proper Great Red Spot longitude, Stellarium wasn't showing that. Stellarium had that problem a number of years ago, but it looks like it's re-emerged. So you're going to have to double check that with some other software or use the Sky and Telescope tool. You can see I've got those web addresses noted there. So the JUPOS will tell you the true location, and then you could use the Sky and Telescope software, the JavaScript tools, or some other software that you may have to double check the location. And we had to doctor or fine tune the number in Stellarium to get it to work. Here are events going on in August. That's just August. And what I'm doing here is listing when there's more than one thing happening at the same time, like a moon transit and a shadow transit, or the Great Red Spot at meridian and a moon transiting, or some other combination of that. So there's tons and tons of things going on here. And there's September. So again, almost every single night there's something interesting going on. All this is on my web article if you want to sort of dive deep into that and circle a few particular dates. I've noted a few with asterisks here that are like really outstanding. So those are really good nights to go look at Jupiter. Saturn is still great, even though it went through opposition back in late July. And while it's below the ecliptic, So not as good a view as we might get. It's still fantastic. It's always so great looking at that planet and seeing the rings. Some of your challenge sort of targets, if you're new to planet observing, is see if you can get that black line between the A ring and the B ring. You can see it quite clearly in that photo by Rick Foster. See if you can see the shadow of the planet on the rings. Obviously, there's many moons around Saturn. They're a little bit more challenging to exactly identify because they're not all lined up in a nice straight line or nearly straight line like they are at Jupiter. So I usually get out some software that accurately renders the positions of the moons to identify them. And I'm also trying for one of the challenge moons, Mimas. Mimas is tricky because it's a small moon. It's only 400 kilometers in diameter. It's very close to the planet. It only goes a little bit beyond the dimensions of the rings, 17 arc seconds from the planet. The chart that I'm showing there with the wavy lines, that's showing you how the moon is orbiting around the planet. The wide sweeping long wave, that's Titan. That moon's easy to see. But you can see Mimas is moving very quickly. It has just under a 1-day frequency. And again, if you can make it out, the light gray line, that vertical line, is the planet dimension. The dark gray lines bordering the planet, those are the rings, and you can see Mimas is just a bit beyond that. So I have not seen that faint moon to date, but I keep trying. And the best time to do that is when it's at elongations. Neptune is coming into view. In fact, it, within this next time period, reaches opposition. So that means the Earth is as close to a planet as it can be. If you drew a line from the sun through the Earth and extended it out into space, it would go through that other planet. So that's the best time to look at planets, to try and see some features or some of the moons. So Neptune is great. It's really colorful. It's below the limit of naked eye visibility, but you should be able to see it binoculars. And if you put a telescope on it, even though it's very small, it's 2.3 arc seconds in size, it still should be quite colorful, a nice deep sort of blue color. And amazingly, even though it's really far away, it's 29 astronomical units. Astronomical unit is the Earth-Sun distance. It's 29 times that distance. Actually, maybe a different way to think about it is that the light travel time to Neptune is over 4 hours. So even though it's really far away, you can see a moon around that planet. Triton is pretty easy to see. I've seen it many times in an 8-inch telescope. So that's something to try for. Again, these moons are a little challenging to see. So try to time it during elongations when the moon swings out quite far away from the planet. Now, I've noted the elongations here for Triton, and in early September, there may be not great times. That's pretty late, but it gets better and better, or easier, more convenient later in September. On the 10th and the 13th, for example, those are happening before midnight. So some cool things to try for there. There's an occultation coming up this month, and it's sort of perfectly placed. You don't have to travel for this. You might be able to do this in your backyard. It has a very high rank, so there's a good likelihood that you'd see it. The magnitude drop, it's not huge. It's just over a magnitude, and it's fairly quick at just over 2 seconds. But the star is relatively bright. It's has a V filter magnitude of 12.5. But the path is neat. Sort of everybody from Prince Edward County through the Golden Horseshoe out to Tillsonburg and St. Thomas, everybody gets to see that. I'm just near the Georgina point on that map, near the G, so I'm beyond the Sigma line. No opportunity for me there. I'm willing to try an occultation again, but it's got to be super easy for me. Anyway, give that a shot. And the asteroid occultation website that's noted there, you can get lots more information and maps and charts to learn more about that. So let's talk about some deep sky objects. Actually, the deep sky objects that are in Scorpius, Scutum, Ophiuchus, parts of Sagittarius, these are all fading away or setting. Scorpius at around midnight is starting to go below the horizon. So this is really kind of the last opportunities that we're getting to look at a bunch of those famous Messier objects and some of the really bright objects near the center of the galaxy. I quite like this image by Jeff Dutton of the Eagle Nebula. So look while you can for those. But what I'm going to propose here is we take an interesting trip, bit of a departure, what I normally do here. Meridian is an imaginary line that runs from the south direction, goes overhead through the zenith, and then off to the north. And of course, it'll go right near the North Celestial Pole, right beside Polaris, continuing on to the north. I mentioned the meridian because that's sort of a rule of thumb. Best time to look at objects is when they're on or near the meridian, because that means they're as high as they can be in the sky. The exception to that is objects that are between the North Celestial Pole and then down to the northern horizon. Ideally, you shouldn't look at objects in that zone because those objects are circumpolar, and 6 months later, they'll be in the opposite side. They'll be in the high part of the meridian. So don't kind of look in this area here if you can avoid it. Wait, be patient, and those objects will climb higher later in the year or in the opposite sort of season. Anyway, let's follow along the meridian and see what we can see. There's lots of neat sort of stuff here. And what I'm going to do is use Stellarium here for kind of our tour of things that we can look at. So let me just do a little switcheroo here. So I'm using the Stellarium desktop software, which is free. The Sky Safari software is another good tool to help you find all these objects that I'm talking about. A lot of these objects are on the observing programs that RASC offers, and if you're going for your certificates, the Messier certificate or the finest NGC, I've got a few sort of subjects for you. Actually, for fun, this is maybe right away starting with a challenge object, but something maybe for fun to try and do is look at Microscopium. Did you know that you can see the Microscopium constellation from Ontario, and you can see all the main stars of the microscope constellation? So that's kind of cool. I've never looked at these objects, but while there aren't any sort of notable deep sky objects or nebula in this area, there's some cool double stars. So there's some fairly bright stars that you can see, like the Gamma star and the Epsilon star, and there's the Alpha, which is actually not the brightest star in that constellation. That's a bit unusual, but that's a good sort of double star to try and see. Moving back sort of towards the meridian, which is this green line that's plotted by the software. It's described as the spectra. I've never heard that name, but that's our globular cluster, Messier 55, cataloged by Charles Messier. And if we zoom into that, we see that kind of the classic globular structure kind of shape, a tightly compact ball of stars visible in the sky. So that's a Messier object to check out. You can see that's just below the planets Saturn and Jupiter that we talked about before. There's another globular that's sort of positioned a bit left of Saturn. So a couple of globular clusters surround our galaxy. They're above and below the disk of our galaxy. There might be hundreds of these. We can't see all of them. The ones that are on the far side of the galaxy are essentially hidden from us, but you could try for those. And again, they're on that certificate program. Another deep sky object to check out, the green sort of circle with the lines here, that's a planetary nebula. Planetary nebulas aren't planets, but they're mostly spherical. They look like a ball under high magnification. They're often colored blue or greenish. So check out the Little Gem Nebula, also known as NGC 6818 from the new general catalog. And that's on the finest list. So if you're working on your finest NGCs with RASC, that's pretty good. If you're looking at the whole sky just with your eyes, you'll be able to easily see a very wide pairing of stars that are up at the top right-hand corner of Capricornus. The stellarium doesn't show it the way I often sort of imagine it, and that's a shape of a bat with outspread wings, and its right wing at the top, where its claw would be. There's a couple of widely spaced stars there. So this is a neat object to look at with every magnification that you have at your disposal. Start naked eye, then put binoculars on it, and you can see some fairly wide stars again. Both the upper one here, that's Alpha or Algeti, and then not quite sure how to pronounce this, Dabi. That star is also a fairly wide double. If I zoom in here in stellarium, you can see a wide pair there and a wide pair there. But then look at these stars telescopically, each of these groups, and you'll split those into more double stars. So there's quite a few double stars just in that sort of area alone up at the top right of Capricornus. A challenge object here, it's way up near the top. It doesn't show in this software. These are star-like objects, but a challenge object is over near the left wing of the bat, if you will, and that's a quasar PHL 1811. That's not terribly far away, but it's one of the fairly easy quasars to see. It's around a magnitude 13 or 14 object, so you're going to need an 8-inch or a 10-inch telescope to see that, and you're going to have to star hop into that region. So that's a bit of a challenge object there. Another planetary nebula along the way is the Saturn Nebula, which, if you get a good view of it, does have these little sort of wings sticking out on the sides that give the appearance of a ringed planet. So that's cool. If we continue moving up here, the meridian is going through Aquila. There's lots of stuff in there. We could spend an hour in there. Aculeus has lots of double stars in it, so you can check that out. There's Delphinus, and I like looking at some of the stars that are in the head of the dolphin, the Alpha star, the Gamma star at the nose, the Delta star, and just around that area, tons of double stars in that area, and some of those are really, really colorful. Scooting over to Sagitta or Sagitta, the little arrow shape there, right kind of in the middle of that constellation, is another globular. That's Messier 71. And then just above it, not far away, is the Dumbbell Nebula. That's a really big but a bit faint planetary nebula, again, also known as Messier 27. This is in Vulpecula. You see it over here? Usually in dark skies with very low power with binoculars, you can see that neat sort of pattern of stars. If I zoom in too much, you don't sort of see it. If I stay zoomed out a bit, you can see that very unmistakable upside down question mark or upside down coat hanger of stars. That's not an official cluster, but or open cluster, but that's a neat target to look at. And if you're in really dark skies and you have really good vision or a good prescription, you might be able to see that naked eye. It's quite small. But that's a neat thing to look at. Back in the middle of June, I was looking just in that area, watching the asteroid Pallas pass through here, and I noticed all kinds of double stars that were not cataloged. So I've photographed them, and I'm trying to sort of reduce that data and submit information about that data, doing a bit of citizen science on objects found in Vulpecula. There's lots of doubles in this area that are known, and a few deep sky objects that are interesting too. In the background, of course, is the Milky Way, so there's lots going on there. And in fact, we're right near Cygnus. So lots to look at there. I've also been trying to photograph the Vila Nebula, and it's huge. It's this massive object that's a supernova remnant, and just to get the western Vale, or is it the eastern? The eastern one, excuse me, the one that's on the left here. That is taking me 12 frames that I'll have to put together in a mosaic. But I've been using H-alpha filters, and it's just a fantastic sort of object there. The West Vale, the one that's on the right with the bright star in the middle, that one's taking me 9 frames or 8 frames to capture all that. And you can see by the background image here in the software, it is still even larger than that with faint elements. Again, we could spend an hour talking about deep sky objects that are in Swan and some of the famous double stars that are in here, and the big North American nebula, which I think I've seen naked eye in a dark sky location. So again, lots of things there, but let's just scoot along. The software is sort of flipping me around because I've just gone through Zenith. That's sort of what's straight overhead. And now we're following along kind of the border between Cepheus and Draco. So lots of good stuff here. Cat-Eye Nebula, and so on. The Iris Nebula, very faint object there. You need dark skies, or that's a challenging object to image because it's got a really bright core like the trapezium in the middle of Messier 42. While we're here looking at Cepheus, if you see the house shape and you look at the one corner of it, that's the Zeta star. And then a bit beyond that, moving outwards from the house, sort of kitty corner from the other corner, there's another star, Epsilon, Cephi. And then you can see a bit to the north here is Delta. And Delta is a naked eye variable star that you can check out. You can easily gauge this just with your eye. Is it as bright as Zeta? Is it as bright as Epsilon? And that's a really quick way that you can gauge the brightness of that. If you're looking for interesting colored stars, there's the Garnet star, or Mu Cephi. I had heard a lot about that. The first time I looked at it, I thought, oh, it's good, but it's not red. I was expecting a really sort of intense red color, but it's pretty good. There's another better star, I think, in this area. Check out that the S Cephi star. It's much dimmer, much fainter, but I think it's a more intense sort of red color, like an ember in a fire. You can see we're pretty close to Polaris here. Did you know Polaris is a double star? So check that out. It's pretty easy to split those. And maybe we're at the end of the journey here, because I said don't look at stuff now from the North Celestial Pole to the northern horizon. But you know what? We haven't looked at any galaxies on this trip. So if you do want to finish off with some galaxies, there's Bode's galaxy, there's the Cigar galaxy. Let's zoom into those. Those are lovely. And so technically, this is not the best time of year to look at these because they're below the North Celestial Pole, but it's pretty compelling. They're sort of close here. And then finally, we're down at our northern horizon. So that was a quick sort of trip through the whole sky, going from the south overhead through the zenith, and we saw lots of different objects along the way. And again, that a bunch of those are on our certificate programs if you're pursuing those. There's a quick note about the programs. I've mentioned objects that are on the Explore the Moon, on the Explore the Universe, the Messier, the Finest NGC, some of the more advanced programs I've noted here. Stay tuned. Our double star observing program should be launched pretty soon this year. And tonight, actually, it's on the docket, it's on the outline for topics with the National Board meeting to talk about the development of a working group or a committee to build an electronically assisted astronomy observing program with an appropriate certificate. So that's in the very early stages there, but that's good news. So I have no idea what my time is, how long I've run here, but if there's any time, I'll take any questions. If you and a question occurs to you later, or we don't have time, you can send a question to that email address, and I'm happy to help you with that. So, Paul, should we?
Yes, let's go ahead with Q&A.
Okay. If there's any.
Anyway, what do you think? Any questions?
Just put out the call for any questions.
Paul, do you have any?
No, I don't think we have any questions.
Okay.
Probably because you did such a great job. Right? Very, very thorough.
Thanks. You can see my credit note there. I use lots of tools, lots of software, lots of paper resources. I thank my photographers for their contributions. So, yeah. There is a question.
That come up?
Yeah.
They just came up. The first one is from Magnolia. I'm currently working on my Explore the Universe certificate. Where can I get feedback on my initial log pages?
Magnolia, if you're with a RASC center, there should be a couple of members that could help you with that. And if not, if you're not with RASC, which is fine, you don't have to be a RASC member to complete the Explore the Universe certificate, you could email me maybe one of your log pages, and I can have a look and give you any comments or suggestions if you'd like. And when you have completed the whole program, you can send that in to any representative on the National Observing Committee. But if you're with a RASC chapter, there should be a couple of people locally that could help you with that.
We have a question from Chris Vaughn. When does the ISS return?
I did not look up the ISS intervals or have a slide for it, but it is in my, it's on my calendar when the passes resume. So I don't have that in front of me, but it is on my PDF calendar. I did note it there. It would take me a couple of minutes to look it up, but of course, a great website that you might use, which I'll just load up here quickly, is the Heavens Above tool. So if you go to heavens-above.com, so here's that website, and there's the address. Notice it's got the hyphen in it. Then you can look up the ISS information. It knows my location, so that's a little bit sort of shifted here. If I look at the ISS passes right now over the next couple of weeks, you can see that they're in the early morning, and then they stop. So that's just the phasing of it, that they're in the morning. Now, if I go forward a bit, we'll see that they start back up. They continue. Excuse me. They do continue into the morning, into early September, and then there's a shift. You can see on the 14th they shift to the evening. So if you're an early bird, for the next couple of weeks, you've got lots of opportunities to see the ISS. And if you're looking at this table and you're trying to figure out, what are the sort of really good ones or the best ones, look for the largest negative number. So there's a 3.8, for example, on the 12th of September. That's an early morning one. And you can see now, clicking on the time, the path is showing. So that's a great website. I also have an app on my Android phone which calculates the ISS passes, and it can issue alerts or notifications. There's lots of good tools like that, good apps that are available. But this is one of our favorite websites that we regularly use. Okay.
All right. Very good. Thank you, Blake. Great presentation, as always. Good to have you. Let's move on to our next speaker, who is Denis Zaytsev. He'll talk to us about INDIHUB, the network of backyard telescopes and citizen science platform. Take it away, Denis.
Hello, everybody. Thank you very much for inviting me to such a great event, the online evening meeting. This is going to be my first talk today at their Astronomical Society. So let's see how it's going to work for me. So today I'm going to present to you my project, INDIHUB, the network of backyard telescopes and citizen science platform. Okay, let's move on. So because it's my first talk, I thought it could be a good idea to introduce myself. So just a little bit about my background and context, how I reached that point in my career building projects like INDIHUB. So I'm software engineer with 18 years in IT. I'm self-taught in astronomy, self-taught in astrophotography. I'm not trained as astronomer, but I'm thinking about it, to be honest. Sometimes I'm very interested in astroinformatics. Astroinformatics, it's a new branch of informatics when you basically join their data science and artificial intelligence with their astronomy and astrophysics. And I believe that's the future. Eventually, I'm very interested in robotic telescopes. That's what I'm trying to build, the network of robotic telescopes. And that's basically what INDIHUB is. My favorite deep sky object is M11. My favorite solar system object is Mars. I live in beautiful Aurelia, Sunshine City, in a Bortle class 5. And again, I'm founder of INDIHUB. And on the right, you can see my setup, one of my telescopes, which is pretty typical for the backyard observatory. Okay, first topic in my talk is what is INDI? I would ask audience, please type in the YouTube chat answer to question if you ever heard about INDI or you already use it. That would help us a lot. And they're just interested in how popular is here among our audience. So INDI is a software library to control astronomical equipment. That's pretty easy. When you buy equipment, you assemble your setup, mount, telescope, cameras, or autoguider, many things. You need to control them. And believe me, it's not easy. So INDI, based on special protocol, which stands for Instrument Neutral Distributed Interface. I know it sounds scary, but the protocol is actually very easy. It's an XML-based protocol, and you can program for it easily. Also, INDI is open source project with a big community. And big community includes developers and backyard astronomers, astrophotographers, even academic institutions. And I like to think about INDI as a software library built by astronomers who also actually working in IT. So it's very user-friendly product and stack of technology. INDI has a big driver library. That includes equatorial and azimuth mounts, CCD cameras, motorized focusers, of course motorized mounts, motorized filter wheels, spectrometers, motorized domes, weather stations, and controllers like joysticks to control your mount. So everything is covered there, and the best thing about it, thanks to their INDI protocol, when new driver is developed for say something new in the market, some new device, some camera, and added to INDI lib stack, all your client software can use it immediately. It's available immediately. You just upgrade INDI lib and that's it. Access to equipment is abstracted via a network server. Clients talk with server over INDI protocol. So this is very interesting concept, and it's very easy to understand concept. You have server running on the side from your equipment. And to control this equipment, you just need to know how to talk to that server, which is pretty easy from point of view software development. And another thing worth to mention, of course, lots of graphical user clients. Really, there are lots of interesting software, and I just put some of them here, which eventually is K-Stars Echos, also apt or astrophotography tool, PhD tool, which is auto-guiding software. It can also actually control INDI devices, SkyCharts, PixInsight, and many, many more. So on the right, you see their indihub.org. That's their address of website. If you want to learn more, just go to that website. And also, I put a little screenshot here. That's actually K-Stars Echos with imaging session for M42 in progress. You can see how it looks like. Another thing I wanted to mention about INDI, they have really good forum, very friendly, probably the friendliest forum I've ever seen on the internet. You can get lots of help here, and just register there, ask questions, you'll get replies like the same evening. Okay, let's move on. What is INDIHUB? INDIHUB is a pretty green project. It was launched in February 2020, this year. As I was saying, it's a network of telescopes powered by INDI technology. INDI is a bare-bone technology for the INDIHUB network. At this time, we already have 72 telescopes registered on the network, and it's still growing. So the network is live and breathing, and this is a very interesting moment to watch it. And also, in terms of features, the core feature of the INDIHUB is equipment sharing. I will be talking a lot about it today. Basically, the flow is you, as a host or owner of equipment, run INDIHUB agent and switch it into share mode. And then, guest you want to invite to use the equipment receives invite and connects remotely to equipment with INDI client. Again, INDI client would be anything like our K-Stars Echos and many, many more. And they're available for macOS, Windows, Linux, or you name it. All traffic, imaging material, as we like to name it, goes through the INDIHUB relays in the cloud. And the cloud runs on AWS. My motivation to start this project was just time when I had lots of cloudy nights, and maybe 6 weeks in a row I didn't have any clear night, and I was thinking that would be so cool to connect somewhere and just to do imaging. And it doesn't matter, is it North America or Africa or Australia? Of course, Australia would be much more better for me, but I just wanted to do some imaging, but I couldn't. So all I could do is just working with existing imaging material and reading books. But then I realized, wait, their INDIHUB has a network nature, and that means we can actually build a network. And I can actually use other people's equipment, and they're willing to share. And then I can provide access to my equipment, and they won't, as reply. So that's how IDEA was born. Okay, so let's speak about INDIHUB agent modes. So INDIHUB agent is a core component, and this is something the owner of equipment runs to be part of the network. It is a software which is running as a sidecar together with INDI server. And the first mode is share mode. You can see, by the way, on the right, the screenshot of INDI Web Manager, which is part of INDI Stack. You just run it to control your INDI software. And you can see that you can easily switch through the interface, the mode, in this case, to share. And then you can see the confirmation, and that would be your address you want to send to your guest. And this connection string will be used in client software by guest to connect to your equipment. So it's pretty straightforward. Share mode just shares your equipment. Solo mode. This is a little bit different. Equipment is controlled only by you. Well, it's very different, sorry. There is no more sharing. In this case, you use your equipment as you usually do. You do imaging, observation, anything else, but all images are still contributed to INDIHUB. So are willing to contribute and send your images. And it's done transparently over network. You don't see how it's all going. So it's your user experience is not influenced in any way. And the third one, which is experimental, we are still working on this, it's robotic mode. This is when you want to share your equipment with network without sharing with person. So you're contributing your equipment to the INDIHUB network as artificial intelligence scheduler, and it's performing different tasks for science projects. So in the future, we'll be accepting requests for follow-up observations, for instance, and you can participate contributing your equipment for this robotic mode. Okay, let's move on. Sharing equipment and remote access benefits. Well, benefits are that observations and imaging sessions could be done from different geolocations. For instance, southern hemisphere. And you can see on the right, I put picture. This is their image of the sky from the Australia or close to Perth, Western Australia. This is something we in Canada will never see, unfortunately, unless we travel to Australia. So with the INDIHUB network, it's totally possible if you find a host in Australia and just do your imaging remotely. Another benefit, there is no need to travel with heavy and expensive equipment. You don't have to anymore. You can just connect remotely, which effectively teleport you to that geolocation over internet. You can try different equipment and setups without buying this equipment or before buying it. You can just find someone with equipment you want to buy and try it, you like it, you buy it. And that prevents lots of pricing mistakes, I think. Another thing, when you have a cloudy night, there is always a clear night somewhere. So that means less cloudy nights and clear skies can be always somewhere. And also you can connect to the most distant locations with close to zero light pollution, and you can actually experience the sky you've never seen. Unfortunately, this is the world we live in. So that will be possible as network grows and we will have more distant locations connected, and eventually you're gonna see that. Okay, let's move on. Let's speak about INDIHUB as citizen science platform. So by design, all imaging data is going through the INDIHUB relays, and this is going to be lots of data. INDIHUB platform already has an image processing pipeline in the cloud, which consists of stack of technologies like Python, OpenCV, which would be a computer vision AI, and we run our own stack of astrometry.net servers for plate solving. This pipeline extracts data from images and annotates them, and they will be extracting lots of data, and INDIHUB as a platform will be providing this data as open API for all third parties interested. And the cool thing about all this, that you're going to be participating. Users will be able to see what was discovered on their images, or in which third-party projects actually your work, your images are used. Also, users will be able to receive tasks from INDIHUB platform and participate in different science projects, say follow-up observations or just some tasks connected with their tracking of asteroids, near-Earth objects, and etc. This is very interesting because your regular imaging night turns into actually contributing to science and planet defense. We'll speak about it a little bit later. And it's totally different level, of course. And that applies to any kind of session, share session or solo session over INDIHUB. The imaging material still gets transferred to INDIHUB platform and into the cloud. So let's speak about projects we have right now in the pipeline, and they're under development actually. So I want to tell you about TrueSat.org project, which was launched about 6 months ago. TrueSat.org is a citizen-powered, again, open source system for creating a trusted database or records of satellite orbital behavior. TrueSat software merges observations of satellites from around the world into transparent record of its location. We have, on INDIHUB side, millions of images with satellite trails, and everybody hates them, I know. And they're not used, especially images from auto-guiding cameras. They just used to guide your mount and compensate their periodic error on your motorized mount. But these images go to nowhere, many of them. Typically, you set exposure for auto-guiding camera 1 second or 2 seconds. So that means thousands of images for one imaging session just go to nowhere, but actually they contain satellite trails. You can see on the right here, that's your typical image from auto-guiding camera, satellite trail. This is very valuable piece of information because by this image we can determine what is the satellite and their actual data for orbit determination. And then we can send it to TrueSat. And all images are precisely timestamped, have geo-coordinates, and they have elevation above the sea. So INDIHUB is a perfect data source for TrueSat. And just a remark about their satellite tracking, it's maybe you would ask, why should we do this? Well, we live in the world when low Earth orbit objects are growing exponentially, and it's busy there. And the purpose of services like TrueSat is to introduce censorship-free and independent source of data, what's going on there. And it's very important to watch satellite operators, because right now, as far as we know, in many situations, when they have to follow some rules or instructions, they're actually powered by business decisions, because every time you do maneuver, satellite maneuver, you actually reduce the operational lifetime of this satellite. And in many cases, it's a business decision. And unfortunately, that's just rolling the dice. So these kind of resources are very important because we are reducing the amount of junk around our planet, and it's just first step for space sustainability, space sustainable exploration. So let's move on. Another project which is under development right now is integration of INDIHUB with MPC, or Minor Planet Center. So as we were saying, INDIHUB image processing pipeline is already working, and it does plate solving. Okay, we have some sorry messages. Sorry, I got distracted. So INDIHUB has this pipeline which does plate solving and identifies moving objects on all images taken by hosts on the network. And on the right, you can actually see a very typical image with a moving object, which is likely asteroid or near-Earth object. What's next? Then astrometry data is calculated for all moving objects found. Think about well-known astrometrical software, but running in the cloud. Then all images, they're precisely time-stamped. So INDIHUB is a great source for observations for MPC. The observations for MPC is actually astrometric data of these moving dots in the sky. And they're very interested to get them. Why does it matter? Well, ask dinosaurs. I'm pretty sure they would explain you in very detail. Unfortunately, they couldn't. Discovery credits. You will be observer, and INDIHUB network will be measured if you find absolutely new object. This is something we still need to discuss with NPC guys, but this is how we see it here at INDIHUB. And again, it's very important, and just think about it. You could actually prevent a very big disaster just doing your imaging session, potentially, we don't know. Or you can participate and you can help NPC to recalculate and clarify orbit elements for all asteroids found. And it's very important because asteroids need to be tracked constantly. They're not stable in most cases, and the orbit elements need to be justified every time we see them. And the more earlier we found that some asteroid or near Earth object is dangerous for us, the better, because it is the only disaster we can actually prevent, natural disaster. And only if we know it as early as possible, like years before it happens. And again, there is no question that Earth is going to be on collision course with asteroid in the future. The question is when. So you can participate in a very important project, and your imaging session might tune into a very important flow here to help defend our planet from their enemies. So that's pretty much it. I just wanted to talk a little bit of the current state of the project. I think I still have some time. And what is next? So network is growing naturally. You don't ask people to sign up or do any kind of registration. It's open sensor approach. You run the INDIHUB agent, you appear in our network. Equipment sharing and remote access is already implemented and it's being used actually. This is exciting time because the things I was thinking about 6 months ago right now are real and they're actually used by people. Integration with TrueSat, it's under development. On that front, we still need to do some work. Integration with MPC, Minor Planet Center, also under development, but we'll get there. Also, INDIHUB Web UI is going to be released soon. This is going to be their web interface to control your equipment right from the browser. And it's going to be one-stop shop to control your equipment or to control someone else's equipment if you invite it as a guest. All from browser, and everything will be done without any software. That's a sneak peek to INDIHUB Web UI. I just wanted to provide it. I know it looks pretty rough, but here we found the object Polaris. You can see that we actually connected to the equipment, guiding camera, main camera, motorized autofocuser, and motorized equatorial mount. And we actually did go to and in tracking mode, and our next step would be that camera icon. Just run your imaging sequence on the object, and that would be basic flow on our web UI. All right. Before questions and answers, QA section, I just wanted to mention that don't forget to go to our website indihub.space. If you have any questions, just drop a message to me to this email address. Our GitHub is here, and you can follow us on Twitter. Plus, you can actually sign up for updates on our mailing list on the website. Okay, thank you very much for listening to me, and in case of any questions, I will be happy to answer them.
Denis, thank you very much for presenting to us. This is an amazing project that you're undertaking, and we definitely wish you great success. And I guess we need to help you spread the word because it's all user-based, so the more the better.
Exactly.
Let's go to Q&A then. Ennio, any questions?
Yes, we have a couple questions from Blink, and I'll post them one at a time. First question, what sort of citizen science is being done right now?
Citizen science right now is again, two projects which are under development. One is TrueSat, or satellite tracking. If you go to the truesat.org website, they have lots of information, and actually tracking of satellites can be treated as a game or as a sport. So INDIHUB will help you to do this just by imaging and doing your astrophotography on the go. Another project is integration with MPC. So in future, not right now, if you're a user of INDIHUB, you will be able to receive tasks from INDIHUB to track different asteroids, which you would be able to see tonight, or track near-Earth objects. Or MPC has a special list of objects nobody knows about, and they need more data about them. That's probably the most urgent task. So this kind of science projects, citizen science projects, will be able to do. And in the future, we can think of many things. Like I've seen on Cloudy Nights forum, some guys actually were able to do search of exoplanets just using pretty standard equipment. And there's some special software. Potentially, we could do this as well on INDIHUB. And there are many tasks connected with just light pollution or tracking passenger jets, for instance, or many, many interesting things, which probably be implemented in next year, not right now. Right now, we are more focused, again, on integration on TrueSat, tracking satellites, and their integration with MPC to track asteroids and near-Earth objects.
Awesome. Second question from Blake is, what are the storage capacities of the system? Because you're capturing a lot of image data.
Exactly. Well, I wish I could say that storage capacity is unlimited, but I cannot say this, of course, for obvious reason. But fortunately, INDIHUB is implemented on AWS, Amazon Web Services cloud platform, and there is a special service, S3, which is very, very cheap storage. And you can store there terabytes of data and still paying almost nothing.
Interesting. And I myself have a question. With the Minor Planet Center that you guys are working with, have they released some sort of an application programming interface to access their data? Are you guys somehow affiliated on the back end somehow?
That's a good question. Yes, the MPC has a whole bunch of APIs to access their data, ephemerals, and everything you want to search in our solar system can be done via their API. Also, they have special API, which I believe was introduced maybe a couple of years ago. I might be wrong, not too far away, I think. That's a special API to submit observations. Before that, to submit your observation, your astrometry as a observer or owner of the observatory on your backyard, you have to send email to them, specially formatted. And if the format is wrong or you miss some little space or new line symbol, that's it. It's not valid. So it was pretty tough process. Right now they have HTTP API where you can actually submit programmatically your observations, and it's quite nice. So this is exactly what we're going to use at INDIHUB.
Any more questions, Enya?
You don't have any at this moment.
Okay, very good. Thanks again, Denis. Fantastic project, and perhaps you could come back and give us an update, I don't know, a year from now or so. So keep in touch.
Thank you very much for having me. I will come back, no worries.
Excellent. All right, so let's move on to our next speaker. Jerry Vila will talk to us about Nicolaus Copernicus.
Hello, I'm good and ready. Thank you. And this is going to be a presentation not about the future, but about the past, and specifically about Nicolaus Copernicus, or Nicolaus Copernicus. He was born in 1473 in Torun, Poland, and he died in 1543 in Frombork, which was Kingdom of Prussia, today Poland. On my first slide, I'm sort of jumping ahead. On your left-hand side is the first page of the first edition of the De Revolutionibus. And that was his research about the orbits of the planets around the sun, which was a revolution in a sense. And of course, on the right is the Mr. Nicolaus Copernicus himself. Young Nikolai came under the sponsorship of his influential uncle Lucas Verzenord, later Bishop of Warmia, that's today Poland, who gave him books and sent him to the best schools. First, Copernicus attended the University of Krakow, then traveled south to Italy, the birthplace of Renaissance, and studied at universities of Bologna and Padua. There he Latinized his name to Copernicus. So from now on, I am going to refer to him as Copernicus. Like Aristotle, Copernicus collected books. Unlike Aristotle, he did not have to be wealthy to do so, thanks to the printing press, invented some 30 years before his birth. Now, on your left-hand side, this is the house where the Copernicus was born, in Torun, Poland. Right-hand side is a second edition of his book that was published in 1543. I am just going to detour quickly to the goldsmith and inventor Johannes Gutenberg. He was a political exile from Mainz, Germany, and he began experimenting with printing. He returned to Mainz several years later, and by 1450 had a printing machine perfected and ready to use commercially. The reason I am sort of detouring to him, because the printing was important for spreading science. Here is the Johannes Gutenberg printing press, and this looks like a printing shop in the 15th century in Europe. Now, Copernicus was one of the first scholars to study printed books, from Aristotle, Plato, Ovid, all the way to Cicero, in his own library, and he studied none more closely than Ptolemy's Almagest, that place Earth in the center of our universe. And this is, of course, is the Greek Ptolemy. Ptolemaic geocentric system did not work very well. It was complicated and required planets to move around the Earth and also on epicycles. However, the Ptolemaic system was fully endorsed and defended by the Rome, as well as Protestant clerics. Martin Luther complained about Copernicus. This fool wishes to reverse the entire science of astronomy, but sacred scripture tells us that Joshua commanded the earth to stand still and not the sun. Prior to the advent of the printing press that I mentioned before, the failing of Ptolemy Almagest could be attributed to errors in transcription or translation. After accurate printing, this excuse began to evaporate. Now, of course, the Copernicus book changed the world. he proposed heliocentric model in his book De Revolutionibus, translated in English, On the Revolutions, in order to repair the inaccuracies of the Ptolemaic system. He was looking for beauty and simplicity. He may have drawn encouragement from reading old Greeks, namely Plutarch, Morals. He also encountered more recent speculations about the motion of Earth from the Parisian scholar Nicolaus Copernicus. After Copernicus returned from Italy, he settled in Frombork and started to compose and calculate, that's important, calculate the revolutionary bus. Again, on the revolutions. He worked in this tower, pictured on your right. And this is the main cathedral on the left in Frombork. In this tower, he wrote the system in longhand and had it distributed among his trusted scholars. This was the heliocentric system that revolutionized the astronomy from then on. This is an illustration from the book. The sun, pictured on the bottom of the slide, was in the center, orbited by Mercury, Venus, Earth, which is the moon, etc. This is the modern representation of the sun and the planets as known in the 15th century. At the time, we only know planets up to the Saturn. The other planets were discovered later. And here they are orbiting in perfect circles. Isn't that a great improvement? Now, about the publication of the Revolutionary Bus. Trouble arose with this publication, not in the incentive for the new cosmology, but in its execution. After hard work to complete a fully realized model of universe based on the heliocentric system, Copernicus found that it performed no better than Ptolemaic model. The Platonic beauty of the spheres and perfect circles did not work very well. Today we know, as Copernicus established, the orbits of the planets are elliptical and the planets move more rapidly when closer to the sun than when distant from it. Copernicus, in fact, found it necessary to introduce Ptolemaic epicycles into his model. Here is the romanticized Copernicus picture that was painted long time ago, and I would definitely say this was painted before 2020. How can I tell? He is not wearing a mask. Publications of the Revolutionary Bus. Perfect system was one reason Copernicus hesitated to publish his hypothesis. For decades, he turned it over in his thoughts, but it would not yield. Copernicus also had a cause to fear censure by the religious authorities, and for a good reason. He only circulated a longhand sketch of his theory among his selected friends. He was an old man before he finally released the manuscript of the Revolutionary Bus to the printer. And the story tells us he was on his deathbed by the time the final page proof arrived. This is the first page of the first edition. This is the first page of the second edition, bit improved. Attacks on Copernicus by Catholic Church. The first notable to move against Copernicus was the Magister of the Holy Place, i.e., the Catholic Church chief censor Spina. who expressed a desire to stamp out the Copernican doctrine. Another Dominican, Tolosani, that attacked Copernicus' system in 1545 in his unpublished work on the truth of sacred scripture. However, there were also supporters of Copernicus, namely Galileo Galilei, who was judged by the Holy Inquisition, and even after he renounced his conviction in 1599, was put under permanent house arrest. Giordano Bruno, who did not renounce the heliocentric system, was burned at stake by the Roman Inquisition in 1600. As you can see, the political correctness wasn't invented in 20th century. However, science marched on, supported by Kepler's discoveries of the laws of planetary orbits in 1609 and by the Newton's formulation of universal gravity and the laws of motion. Heliocentric system survived. Due to the waning fortune of the Ptolemaic and Aristotelian model, when a bright comet was discovered in 1577 and by the appearance of brilliant nova, that supernova 1572, also Kepler observed another bright nova in 1604. Now here is the gallery of Copernicus supporters. This is Nicolaus Copernicus, Tycho Brahe. Well, he actually had a somewhat different system from Copernicus, but I will skip over it for now. This is Johannes Kepler, Giordano Bruno, Galileo Galilei, and finally Sir Isaac Newton. By the middle of 17th century, the Copernicus system was recognized by the majority of scientists. Today, of course, we know more about the planetary motions than what was known back then. In fact, if the inventors of the heliocentric system would have more detailed data, they would get somewhat confused. For example, this is the Earth's orbit around the Sun from the galactic perspective. So you can see, depending on your perspective, the things can move quite differently. Furthermore, I couldn't resist to put my picture here. This is the elliptic orbit and precession of the Mercury, as it was discovered in 20th century. As you can see, the elliptic orbit of Mercury is shifting. That's called precession. Here it repeats. This is not Einstein. This is Kepler, calculated in many body system. The Sun from Mercury is almost 3 times the size. I mean, the disk of the Sun is 3 times when viewed from Mercury than viewed from the Earth. And it's a rather complicated system to calculate. But it is respecting Kepler's law. It's not Einstein. Only in 2008 were the remains of Copernicus positively identified by DNA, and he was reburied in the same Fromburg Cathedral in 2010. And that was with great honors. Copernicus remains were reburied at that cathedral, as I mentioned, May 2010. This is the casket with Copernicus remains, and this is his final burial place in Fromburg Cathedral. That's exactly where he was found originally. The way the DNA tests were done, that they discovered a hair in his library. The library was in that tower in Fromborg, and the DNA was finally matched to the skeletal remains. I think I'm doing fine on time, and there is one more slide, but that's not the end of the show. This is the Nicolaus Copernicus monument in Krakow. That's where he first went to the university. There's also a museum, I believe, in Warsaw. There is a university in Łódź, both dedicated to Nicolaus Copernicus. There's a bit of controversy because Germans, they claim Copernicus was German. In Poland, it's claimed to be a Polish person. So thank you very much for your attention. I hope you have some questions. But before I go, I have one more slide for you and a little video. This slide talks about the modern telescopes, and we heard quite a bit about them today. And of course, there are planetary probes, and they provide much improved understanding of our universe, such as type of stars, planetary nebula, cosmic distances, etc., etc. However, what also helps is to view broader perspective. Sometimes it helps to step back and look at the bigger picture. Well, Andrew, please let me show what I mean. Andrew, are you there?
That's a funny one. Thank you very much, Jerry, for sharing that with us.
And I thank you for your attention. And if you have any questions, please let's hear them.
Go ahead, Enya.
In the chat, Blake asks, how did Bruno support Copernicus?
How did Bruno support Copernicus? He supported him by accepting this theory of planets in the orbit around the sun. That was his conviction, reading Copernicus' thesis on the subject. And he stood behind Copernicus. He did not recant.
Interesting. We have another question.
Sure.
ANAF. Do you know if there were other scientific truths from other fields of science which could not be spoken openly at the time of Copernicus?
Well, I would say absolutely yes. Let me give you an example. A few centuries later, when somebody is knocking on my door right now, but give you a quick example about Darwin. he also very much hesitated to publish his book on the species because he was very much afraid that he would be radical. So that's just one example, and there were many in between. Does that answer the question at least? I have to check my door. Sorry.
All right. Well, we'll end it. We'll take a break for a moment. We need to set up our next. Actually, it's actually our president with the announcements.
Okay, Blake, we'll start up with the...
All right. So I didn't have a chance to thank Denis. Denis, if you can hear, I'm sorry, Jerry. Jerry, if you can hear me, thank you for a well done presentation. Thank you very much for volunteering to present. So that concludes the speakers lineup for this evening. Let's go ahead with our President Ralph Chu and the announcements for this evening.
Okay, thank you very much, Paul. I'd like to begin by just thanking Blake, Denis, and Jerry for their contributions tonight. It's great to have such a breadth of topics to hear on these programs. Well, let's take a look at what's coming up, and our next slide will show you the program for our next meeting, which is indeed another of our recreational astronomy nights online. We don't have anything as yet finalized.
We do.
Oh, have we?
Yes.
Late breaking.
Well,
So,
no.
okay.
Yeah. So if I can take over for just a second. So Chris Vaughn is going to take care of the sky this month. We're going to have an interesting presentation from Doug George and or Colin Hegg from Diffraction Limited, who also now own S-Big Instruments. So they're going to give us a product update from Ottawa. And then we're going to have Arushi Nath, who will talk to us about her journey through the universe in the past 6 years to complete her RASC Explore the Universe certificate.
Marvelous.
And there is one spot available, about a 15-minute slot available for a fourth speaker.
Okay, great. That's good to know. By the way, I'm not sure if anybody knows this, but Artash and Arushi were the recipients of a prize from NASA recently for developing some projects that earned them a COVID project award. I caught that on, of all places, CTV News Online. And Arushi was interviewed by the online host. So I'll say congratulations to Artash and Arushi on that, and hopefully they'll mention the exact prize when they do the presentation in September. Okay, our next slide is for our first lecture meeting, and that is going to be on September the 30th. We'll be hearing from Alyssa Albertus from the Dunlap Institute at the University of Toronto. She is studying exoplanets, and so she'll be giving us a talk on that subject. Paul Delaney tells me that he has got speakers lined up for October and November as well. We just need to pin down the titles of their talks and get a summary to post on our website. So our lecture lineup is set right through to the end of the fall session. Okay, next slide is going to just talk about education and public outreach activities. Although our in-person EPO activities have been suspended, we are starting to get active online. Recently, the Science Center hosted a virtual star party, the first one it's done, and that was organized by Rachel Ward Maxwell, and a number of people in the Toronto Center volunteered to help out with that. So Tanya Alexic and Blake Nancarrow helped to organize things. We had Andrew Reed doing his wonders with Zoom to connect everything. Chris Vaughn was our online presenter. And we had telescope feeds from the eyepieces of Claudio Oriani and Francois Van Heerden as they played Dodge 'em with the Clouds that evening. And they actually did get some views online. So it worked out quite well. In the meantime, Ian Wheelband is working with the Dunlap Institute to organize a virtual star party along the lines of our planetary observation night that we've hosted with the Department of Astronomy and the Dunlap Institute at the University of Toronto campus. A similar event is planned for September, but it will again be online. And just this afternoon, I had the second of a number of planning sessions with the City of Richmond Hill to talk about doing some virtual star parties for the Mars opposition in October. And as those plans crystallize, we'll be getting information on those two virtual star parties online on our website. So there is stuff going on, even though the emergency and the pandemic are sort of hampering our style, but things are moving along. Okay, next slide. Here's something for our next DDO program. Although the observatory itself is undergoing major updates, the windows are all being replaced on the administration building, and there's various repairs being done on the 74-inch dome. Nonetheless, we are continuing to offer virtual programs under the DDO banner, and our next presentation is by Dr. John Moores of York University. He's no stranger to the Toronto Centre, and his talk will be Methane on Mars, Fact, Folly, or Figment, and should be a really interesting talk because John is very much involved with Mars research with NASA and other organizations. So that should be a really interesting talk, and that will be on our YouTube channel. Okay, next slide. Observing. Again, our in-person formal observing star parties have been suspended because of the pandemic, and I'm not sure when we're going to be able to resume those, but in the meantime, we are trying to take advantage of virtual star parties and things like that, and perhaps there will be an opportunity to do something that way, but it remains to be seen. Next slide. Okay, here's the planet party details so far, as far as the Dunlap Institute program is concerned, on Saturday, September 12th. And we'll hopefully be able to get some people involved with their telescopes and camera feeds to help with the virtual observing. And there's some other things that the Dunlap Institute people are organizing. So again, that program will go ahead, and hopefully the weather will cooperate for that event. Okay, next slide. A reminder that there are the continuing online programs being offered by the National Society. Among them, we have the speaker series, and a variety of other programs that you can find out about through the national website, rasc.ca. So please take a look there, and if you get a chance to participate in that, great. The CAO, in the next slide, we have been working very hard to try and bring the CAO back online. We have all sorts of precautions and preparations in place, and you can now book online. And a number of members have, in fact, responded to Ian Bilban's announcement on our forum and through MailChimp. And so we are getting people to book, and hopefully people will be able to take advantage of the darker skies up there and do some observing at the CAO. I'll be heading up there this weekend to cut the grass and bring up some more supplies, including hornet spray. Apparently we have at least one nest that has taken up residence in one of the observatories, so we need to get rid of that to make the place safe for everybody. But again, the CAO committee has been working very hard to try and make sure that things can proceed. And so we do have openings available to book the site. Okay, final slide is something that I've talked about previously, and that is that we do have a lot of things going on. I listed the volunteers who were involved in the Science Center Virtual Star Party. And, you know, behind the scenes, there's many things that we rely on volunteers to help out with, not only in EPO, but also with various activities that and services that we offer to the membership. And so please, if you have some spare time and would like to help out, do contact our volunteer coordination team of Alex and Blake to you know, see where we can use your talents and your time to provide these services. Again, it's important work to keep things going as we move forward into the next session. So that's it for now. Thank you again for tuning in tonight, and we'll see you online in the future. Good night, everybody.